Myself Sourav Pattanayak, Assistant Professor of Mechanical Engineering Department, Haldia Technology. I am going to discuss the topic principal stresses and principal planes from the subject strength of material. So before going into detailed discussion about the principal stresses and principal planes, we have to understand what is the compound or complex stress system. Suppose if we consider any structural component subjected to uniaxial stress, then for different inclined plane, there are two stresses are present, which are normal stress and shear stress. So if we consider different plane for different angle theta, we will have different sigma n, which is normal stress, and tau. So from the design point of view, when a plane in a straight body is oblique to the applied external force, then this plane may be subjected to direct or normal stress and shear stress simultaneously, which stress system is known as compound or complex stresses. Now, what is principal stress and principal planes? So, under the action of any compound stress system, suppose along x direction sigma x, y direction sigma y, and tau xy. In this stress system, which is compound stress system, if we consider any inclined plane at an angle of at any particular angle, so we will found one particular plane where the resultant stress is wholly normal. That means there is no shear stress present. There is no shear stress present. So this particular plane is known as principal plane, and the stress on this principal plane is known as principal stress. So in summary, we can say that principal stress are those stress which are present on the planes where shear stress is absolutely zero. Next, what is the application? Why do we learn this principal stress and principal planes? Because calculation of principal stress is important for determining the maximum stress a structure is exerted when it is under the action of compound or complex loading. Next, this principal stress will be a very important design criterion to prevent the material failure. And if we consider this principal stress while designing any structural component based on the material properties or the maximum load, maximum stress that can be withstood by a particular material, which helps in ensuring the safety and reliability of the design structure. Next, before going into the detailed mathematical derivation of the principal stress and the planes, we have to understand what is the stress on any inclined plane. For this purpose, we have considered this element which is under the action of complex stress system, which is sigma x, sigma y along y direction. These two are the normal stresses, and tau xy, which is the shear stress. So in this configuration, if we consider this inclined plane at an angle of phi, then we will be able to calculate the normal stress and shear stress, sigma and normal stress, tau shear stress on this inclined plane. So for this calculation, if we only consider this element, so each and every faces on AC face, the stress is sigma x, and along the y face, BC face, sigma y, and along BC plane, the parallel stress which is tau xy. Similarly, along AC, there is tau xy. So in this configuration, our objective is to find out the sigma n, which is the normal stress on inclined plane AB, along with the shear stress tau on the inclined plane AB. So just equilibrium equations we have to apply. along x and y direction by multiplying the area, and for this calculation we have considered unit width. That is why the surface on which sigma x is acting is basically AC length into unit width. So from this calculation we can calculate the final expression of normal stress and shear stress. So normal stress, which is denoted by sigma n, basically normal stress on inclined plane AB, this inclined plane AB, okay, which is basically sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into cos 2 phi plus tau xy sin 2 phi. So phi is the inclination angle. Similarly, on this face AB, tau, which is the shear stress, equal to sigma x minus sigma y by 2 sin 2 phi minus tau xy cos 2 phi. So once we have the formula or the final derivation of this normal stress sigma n and tau, we will be able to calculate what is the maximum possible normal stress sigma n, and this maximum possible normal stress on this AB plane, inclined plane AB, is basically known as principal stress. So there are two ways to calculate either maximum or minimum normal stress sigma n or zero shear stress tau, because from the definition of principal stress we know that on the inclined plane, on any plane, if the total stress is wholly normal, that means no shear stress is present, that is known as principal stress. Another way we can say that on any inclined plane, if the normal stress is either maximum or minimum, this plane is known as principal planes and the corresponding stresses are known as principal stresses. So how do we calculate? Mathematically, how do we calculate the value of principal stresses? Basically, maximum sigma n and minimum sigma n, which is designated as sigma 1 and sigma 2. So this sigma 1 and sigma 2, these are known as principal stresses. Major principal stress, minor principal stress. So there are two ways to calculate. First of all, for minimum and maximum value of sigma n, we can differentiate sigma n with respect to phi, because for any inclined plane, this phi is variable. So there are various values of phi. If we take another plane, there is another value of phi. So this phi is a variable. So for one particular value of phi, sigma n is either maximum or minimum. Okay. So that is why if we differentiate this sigma n quantity with respect to phi and equate it to 0, finally we will get the value of 2 phi. And another way, as the principal planes denotes the zero shear plane, another way we can calculate by equating shear stress equal to 0. In the previous topic, that is sigma n and tau, either we have to differentiate this one, d sigma n by d phi equal to 0. Another way, for principal planes, tau equal to 0. From this two way, we will be able to calculate the value of phi where this sigma n is wholly normal, either maximum or minimum, and the value of shear stress is 0. So by equating either shear stress equal to 0 or differentiating sigma n with respect to the angle, inclination angle phi equal to 0, we will be able to calculate 2 phi equal to tan inverse 2 tau xy by sigma x minus sigma y, or phi equal to half of tan inverse 2 tau xy divided by sigma x minus sigma y. So once we have the value of phi, we will be able to calculate the principal stresses sigma 1 and sigma 2. Because why we are getting two values of sigma n? From this expression, we have two values of phi. Basically, if we consider only 2 phi, so this 2 phi which is differed by 180 degree, so that phi 1 and phi 2 they are differed by 90 degree. So that means if two values of phi phi 2 equal to 2 phi 1 plus 180 degree. So phi 2 equal to phi 1 plus 90. So that is the way to calculate the principal planes. That is the way to calculate the principal planes. So next, in the expression of normal stress and shear stress, that is sigma n and tau, if we put two values of phi 1 and phi 2, we will be able to calculate major principal stress and minor principal stress, which is the maximum and minimum normal stress on the principal planes. So once we have the value of this 2 phi, already I have discussed 2 phi 2, 2 phi 1. So from this 2 phi 2 and 2 phi 1, in the expression of sigma n and tau, there are sine 2 phi and cos 2 phi. Sine 2 phi and cos 2 phi. So from the value of tan 2 phi, we have to find out, from the value of tan 2 phi, we have to find out sine 2 phi 1, sine 2 phi 2, cos 2 phi 1 and cos 2 phi 2. So how do we calculate this? So if tan 2 phi equal to 2 tau xy by sigma x minus sigma y, if we rearrange this, tau xy by sigma x sigma y by 2. So from this expression, we can find out the value of sine 2 phi 1 and phi 2. If it is tau xy, this is sigma x minus sigma y by 2, sigma x minus sigma y by 2 whole square plus tau square xy. So from this, if we want to calculate sine 2 phi 1, that will be tau xy divided by under root sigma x minus sigma y by 2 whole square plus tau xy square. Similarly, cos 2 phi, sigma x minus sigma y by 2 divided by under root sigma x minus sigma y by 2 whole square plus tau xy square. So as 2 phi 1, 2 phi 2 equal to 2 phi 1 plus 180 degree. So sine 2 phi and cos 2 phi for this particular condition will be minus. So minus tau xy by same thing and minus sigma x minus sigma y by 2 divided by same thing. So if we put all the value for major principal stress or maximum normal stress sine 2 phi 1 and cos 2 phi 1, if we put these two value in the expression of sigma n, we will get the maximum principal stress, and if we put these values sine 2 phi 2 and cos 2 phi 2 in the expression of normal stress on any inclined plane, then we will get the minimum principal stress, which is minor principal stress. So after putting those values in the expression of sigma. So if we put the value of two angles sine 2 phi 1 and cos 2 phi 1 in the expression of sigma n equal to tau x, sorry, sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 phi plus tau xy sine 2 phi, which we have obtained from the expression of normal stress on any inclined plane, sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 phi plus tau xy sine 2 phi. So if we put the value of sine 2 phi 1 and cos 2 phi 1 in the expression of this sigma n, we will get the maximum normal stress. Okay, and finally, maximum normal stress or the major principal stress sigma 1, which is basically sigma x plus sigma y by 2 plus under root sigma x minus sigma y by 2 whole square plus tau x whole square. So in this expression, again, in this expression of normal stress on inclined plane, if we put the value of sine 2 phi 1, sorry, 2 phi 2 cos 2 phi 2, then we will get the value of minimum sigma n, which is basically minor principal stress denoted by sigma. So that is all about the mathematical derivation of principal stresses, maximum normal stress sigma 1 and minimum normal stress sigma 2 for two values of angle, that is phi 1 and phi 2. The difference between this phi 1 and phi 2 is 90 degrees, which means phi 1 indicates the major principal plane, phi 2 indicates the minor principal plane, and the difference between these two planes is 90 degrees, that is they are perpendicular. So for this one, if we want to represent the direction of principal planes and the corresponding stresses, so if it is xy axis, so this angle is phi 1, that is this plane is basically the major principal planes. On these planes, sigma 1 is acting, which is maximum normal stress, and another plane which is at an angle of phi 2. So on these planes, the stresses acting, which are basically minimum normal stress or the minor principal stress. So that is all about the discussion of principal planes and principal stress.